A single misconfigured BGP session took down DNS for half the internet for 15 minutes. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover IP addressing and Anycast. Anycast is a network addressing technique where multiple servers share the same IP address, and traffic is routed to the nearest server based on BGP metrics. It's how CDNs and DNS root servers achieve low latency and automatic failover. Anycast lets you announce the same IP from multiple locations. The Internet's routing system sends each user to the closest server. It's like a chain of coffee shops with the same name. You go to the nearest one. Each site advertises the same IP prefix via BGP. Routers select the route with the shortest AS path. If one site fails, its BGP session drops and traffic shifts to the next closest site after convergence. Here's a production BGP configuration snippet. Each Anycast node announces the same prefix. As path prepending makes a path longer, so it's less preferred, useful for balancing traffic across sites. This config sets up BGP on a Cisco router, advertises the Anycast prefix, and prepends the AS number 3 times to make this site less preferred. Adjust prepending to balance traffic. Anycast is ideal for stateless services like DNS or HTTP redirectors. For stateful services, terminate TCP at the Anycast, load balancer and proxy to backend servers using unicast. This avoids connection resets during failover. This HA proxy config binds the Anycast IP on port 80 and load balances to backend servers via unicast. The Anycast IP is advertised via BGP from this load balancer, providing regional routing and failover. Anycast has 3 common failure modes: BGP route flapping, asymmetric routing, and hot potato routing. Never use Anycast for database connections. Stateful connections will break on failover. Use Anycast for fast failover and low latency. Use DNS load balancing when you need fine-grained traffic steering. Many production systems combine both. DNS returns an Anycast IP, and Anycast handles regional routing. The article states BGP convergence takes 30-90 seconds, but with BFD and fast external failover, detection can be sub-second. However, full route propagation across the Internet may still take tens of seconds due to route processing and policy. Always test convergence in your specific network. The article mentions BFD, but doesn't show configuration. Here's a Cisco IOSXE snippet enabling BFD on the BGP session for sub-second failure detection. The article's incident highlights the risk of accidental BGP withdrawal. In production, monitor BGP sessions state with alerting on state changes, e.g., from established to idle. Use tools like Prometheus with BGP Exporter or SNMP traps to detect flaps immediately. When Anycast breaks, use traceroute and MTR from multiple vantage points. On your routers, use Show IP BGP to check the best path and session state. For a global view, use RIPE Atlas or Thousand Eyes. These commands help diagnose Anycast issues. Traceroute shows the path, MTR monitors continuously, and BGP commands reveal route advertisements and session status. This is the same issue we highlighted at the start. Here's exactly why that happened. A single Anycast node had a misconfigured BGP session that caused it to withdraw the Anycast IP for a root DNS server. The withdrawal propagated globally, and the remaining nodes couldn't handle the traffic spike. BGP convergence took 15 minutes. The fix was to re-establish the BGP session and add prefix list filters to prevent accidental withdrawals. They also implemented BGP session monitoring with alerting on state changes. This prevents a single misconfiguration from taking down global services. A single no network command can withdraw the Anycast prefix, causing a global outage. Always use prefix list filters and BGP session monitoring to prevent this. Never put Anycast IPs on database servers. Stateful connections will break on failover. Use a proxy layer or DNS-based routing instead. Using different upstream ISPs can cause asymmetric routing, where forward and return paths differ. This can cause stateful firewalls to drop packets, use the same upstream ISP, or manipulate MED values. When users report high latency or timeouts, start with traceroute from their region. Then, check the BGP table and sessions state on your router. Look for route flapping using Show IP BGP flap statistics. Let's run through some common interview questions. How does Anycast handle TCP failover? TCP connections break. Use proxy termination. Anycast versus DNS LB. Anycast for fast failover, DNS for fine-grained control. What causes asymmetric routing? Different upstream ISPs. Fix with same ISP or MED. And a few frequently asked questions. What is Anycast? Multiple servers share an IP, traffic goes to nearest. Anycast vs Unicast? Unicast, one IP per server. Anycast, same IP on many. How to implement Anycast? Own ASN and IP prefix, configure BGP on servers. To recap, Anycast lets multiple servers share an IP for low latency and failover. It's great for stateless services, but for stateful ones, terminate TCP at the proxy. Use BFD for fast failover, and remember Anycast is topological, not load-aware. Ready to go deeper? Up next, database replication, then database sharding, then database indexing. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.